Okay. I have three questions. Really like your hair. Thank you. That looks nice. Are you ready for the bathroom?
What?
Are you ready for your bathroom?
Yeah, I don't have yours yet because the process has started, but I wasn't satisfied yet. So
Okay.
it'll
You do
appear in
realize
the
it's
walker
like-
at some point.
What? Okay.
Yeah.
It's not refined yet.
It's not
Happy
refined.
Valentine's Day.
Oh, that's really scary.
There you go. Wow, you even got the tape here to hold it together. Yeah. That's great. Thank you.
That one exactly how I
Okay, good. Yeah, that was gonna come with like this awesome like
Yeah, I think maybe
thing.
Mine will be just as good. You look at it. That's your face.
Yeah, well, you put in my special oil last night. I just want to build on this hair.
You need to write this down.
So I thought we were going over homework.
So, study hall, profile, your last focus.
I had no idea
Okay,
what to do for
thanks. Did you get some?
For which question?
17.
17.
I said-
Answer for
Oh,
17.
this was yesterday?
I got
Oh.
Yes.
You got an answer, okay, I didn't get an answer.
I got no.
You guys can wait on the notes for a minute if you wanna get out your
I
homework.
did get,
Please.
Did you
but
get I didn't get 29.
29.
I think
I was
I did.
confused on 19.
Well, I got an answer, whether that's right is debatable.
No. Yeah, that's it.
They're threatening
Last
us.
time was
Okay.
Yeah. Oh yeah, I did get an answer.
Hannah, why do
Oh,
you have a
visit.
page?
It was really good. I liked it a lot.
Why do you have a
Good.
page?
Okay, let's look at 29.
I didn't notice that.
Okay.
Let's go.
Okay. 5 halves and 3 halves. Find two possible values for the length of the third side.
What number is this? 29.
Okay, so it could either be 5 halves plus 3 halves equals, or it could be x plus 3 halves equals. You just didn't want to do fractions, is that it? So this would be 25 fourths plus 9 fourths, which would be 34 fourths. Square roots. So square root of 34 over 2, and 34 is what, 2 times 17, so that won't, yeah, that won't simplify. So square root of 34 over 2, and they all have common denominators, so really it's not that would be 16.
So when you're doing these, you're just multiplying the numbers by whatever the,
You have to square the top and the bottom.
oh, right, okay. Oh, I was looking before. Okay. And then what's the part at the bottom that the square root is for?
So to get the x by itself, you have to take the square root, and this means square root of 34 over the square root of 4. So the square root of 4 is 2, and square root of 34 won't simplify, so you just do that.
Okay.
I got this, like I got 2 for that one, but for the other one, I didn't do like the improper fraction. I did like 2 and 1/4 plus 6 and 1/4 equals 8.5 because I squared top. So I have like my answer is square root of 8.5. Is that
Yeah, don't do that.
okay?
Yeah, leave them as the improper fractions.
Okay.
Yeah, mixed numbers aren't very helpful usually in math. They're more helpful for like everyday stuff, like doing a recipe or something like that. But yeah, I wouldn't change anything to mixed numbers generally speaking. Aaron?
Can you do number 19 and 21? These ones just confused.
I'll do one. The length and width of a rectangle are 6 and 4. Find the length of the diagonal. I guess that's more. I'll just draw you a picture of that. And 21. Quadrilateral is a square. If AC is 12, find AB. Okay, so 19 is pretty straightforward. I would just draw a picture so you can see where the right triangle is. Rectangles and squares have all right angles, so the corners will all be 90-degree angles, so right triangles. So if you know the length and the width, you can find the diagonal using the Pythagorean theorem. Do you see this triangle here? Yes? Okay.
Oh, okay.
What? I
did not
Are
see
you
that.
laughing at me? There's something.
Oh, I just realized I don't remember what that is, so I'll have to explain.
The Pythagorean theorem?
Yeah.
Oh, well, that's what all what we did on Friday.
Okay.
That's the only thing.
That's,
And then for 21, since 21 is a square, that means all the sides are the same. So you have to find A, B, which it doesn't really matter which one you call A, B. They're all going to be the same. So with this one, you're going to have to use the same variable twice, and this 12 would be the hypotenuse. So I would say x squared plus x squared equals 12 squared. Whatever letter you want to use is fine. But since all the sides are the same, we can use the same variable for the 2. And so this would give us 2x squared equals 144. And then divide by 2. So x squared equals 72. And then square root. 72 is what? 2 times 36. So 4 and 9 are both. 136 is so 6 square root 2. Right? Does that help?
Yes, yes,
Yes?
Thank you.
Anybody else have questions? Mark?
It's on a different one.
Are we good on these two? Okay, Morgan.
For 17, if you square a square root, would you just, how would that work?
4 square, I would have to figure out, what 4 square root 3 is with the decimal first, which maybe you guys have already done that, to figure out which is the longest side, and it's 6.9. So the longest side would be 8. So 4 squared plus 4 squared, 3 squared equals 8 squared, or we're trying to see this. Okay, so this means 4 will be squared and the square root of 3 will be squared. Well, when you square the square root of 3, it undoes the radical sign. So that would just leave you 3 times 4 squared, so 3 times 16. Does that make sense?
Yeah.
So 48. So the 4 part needs to be squared, the square and the square root will undo, but then you multiply the 4 squared times the 3. So yes, that one is a right triangle. Okay?
I actually have a question on 21.
Okay.
How did you get the end part, like the x squared to the 6? Is that just this,
To go from the square root of 72 to this, you mean?
is that the factor?
Yeah.
Okay.
I kind of tried to do it quickly, because I
Okay.
thought you guys might have. But yeah, like you did with the simplifying radicals, if you make the tree and then take out the factors that are matching. Okay? Anything else? No? Alright, then, go ahead and get out your notes, we already started, fine. So has anyone in here taken the SAT or ACT? No, have any of you been studying for it? I feel like Lauren told me that these are on one of those 2 tests, and I don't remember which one it was. But that she saw a lot of them somewhere on one of those. So, you can see special right triangles. So there's 2 kinds of special right triangles. And so we have 2 theorems for them in your book. The 45-45-90 triangle. So 90 being the right angle and then the other 2 angles are 45. And then there's a 30-60-90 right triangle. Okay, so in a 45, 45, 90 triangle, there is a special relationship. Each of the legs are going to be congruent to one another. And the hypotenuse would be square root 2 times the length of one of those legs. So if L is representing the length of a leg, then the hypotenuse would be L times the square root of 2. And that's what theorem 7.4 says, and we call those 45, 45, 90 triangles based on their angle measures. And then theorem 7.5 is on the 30, 60, 90. So the 30, 60, 90 is a little more complicated. If we say the shorter side is A, which is just any letter really, any variable, I just picked A. And then the hypotenuse would be 2 times A or 2A, and the longer leg is square root 3 times that, so A square root 3 for 30, 60, 90. The shortest leg will be opposite the 30-degree angle, the longer leg will be opposite the 60-degree angle. Okay, go ahead and get out your books and turn to page 244. Okay, we're going to start on page 244. We're going to do some examples starting with number 11. So at number 11, they give, or 11 through 14, they give you a 30, 60, 90. I know normally you don't write these in your notes, but you might want to today. So we have D, E, F. Okay, so 11 tells you that EF is 4. Okay, I'm going to draw that over here, but we're going to be changing it, so you might not want to. But EF is 4, and they want you to find DF. So I'm going to put an X for that. So if we think about the relationship, what I a lot of times do is just write the relationship on the triangle. So I find the shorter leg, which would be the shorter leg. FE, and I write A, the same things I wrote on the last picture, which is the longer leg. DE, so that relationship is what?
2A, or 2, 10.
That is the hypotenuse. The hypotenuse is 2A, and
yes.
the longer leg is
Square root 2.
A times square root of 3. Okay, so if you put that on there, and now we see A is 4, then X is going to be 2 times A, so that would be 8. Okay, so that would be, for DF would equal 8. Okay. For the next one, they give you EF is 3, and they want you to find DE in this case. So if A is 3, then DE would be A squared root of 3, which would be what? 3 square root of 3. And you can leave it like that. That's simplest radical form. 13, if DF is 10, then EF is what? Okay, so this time I have the 10, which is the 2A, then EF, Madeline?
That would be 5.
It would be half of that would be 5. Does anyone have questions so far?
I don't understand it. I don't know how you're getting these things.
Okay. This is where everything's coming from. Okay, so in this last one, 13, we had DF is 10. So that, let's say 2A then equals 10. And I'm trying to find A, because they're asking me to find EF. So then I could solve this equation for A, divide by 2, so A would be 5.
That makes sense. So for each one of these problems, is it gonna be like DF is 2A and DE is A squared root of 3?
All the
Like
30,
it's gonna
60,
say-
90 triangles will have those same green relationships.
Okay.
Yes. And I think you'll get the hang of it once you do it. And then the last one, they give you DF is 12 and you have to find DE. Okay, I'll show a little bit more work. So DF is 12, so I'm going to say 2A equals 12. And we'll go ahead and solve that for A. So A would be 6. Well, DE is A square root 3. So that would be, if A is 6, that would be what? 6 square root 3. Okay. Any other questions? Okay. And then 15 and 16 are referring to the 45, 45, 90 triangle. Okay, if PR is, let's go ahead and write the relationships. So the relationships for 45, 45, 90, you can use A again if you prefer. I used L for leg in the other part. But if you want to use A to keep it consistent, we could say this is A, and A square root 2. Or L square root 2, or whatever letter you want to use, it doesn't really matter. But the two legs will be the same length, And the hypotenuse would be the leg times square root 2. So there's the relationships, which I would always write down on the 45, 45, 90 or 30, 60, 90 triangle. So then if we have PR is 7, then we know that A is 7, and we need to find RS. RS is A, and so RS would be here's 7. They're congruent. You probably don't need, some of you don't need to write that down, some of you do. It's up to you. Questions? Okay, 16, SR is 6. Then PS is what? So A is, excuse me, A is 6. PS is A square root 2. So PS would be 6 square root 2. Okay, your assignment is page 245, numbers 1 through 31 odd. Question for you before you start that. If you have a triangle, and you know that this is 90 and this is 60, can you tell if that's a 30, 60, 90 triangle? Yes, because
If you a triangle equals 180, so if you add 90 and 60 together and subtract it from 180, you would get 30.
right. So they really only need to tell you, if it's a right triangle, they only need to tell you one of those other angles and you can make your own assumption, or not assumption, but you can conclude that this is a 30, 60, 90 triangle. If they give you a 90-degree angle and they tell you one angle is 45 degrees, you can conclude that's a 45, 45, 90 triangle, because there's only one other measure the other angle can be. So they don't need to tell you all 3 angles for you to know that it's a special triangle.